What is an extensive property in thermodynamics? Have you ever wondered how the size of a system affects its properties? In thermodynamics, this question leads us to the concept of extensive properties. An extensive property is a physical quantity that changes based on the amount of substance or size of the system. This means that if you increase the mass or volume of the system, the value of an extensive property will also increase proportionally. For example, think about a container filled with gas. If you were to divide that gas into equal parts, each part would have half the mass and half the volume of the original container. This illustrates how extensive properties like mass and volume depend on the quantity of material present. In contrast, there are intensive properties, such as temperature and pressure, which remains constant regardless of the system size. This distinction is important in thermodynamics because extensive properties help us understand the total quantity of something within a system. They are also additive for subsystems. For instance, if you have two separate systems, the total internal energy of the combined system is simply the sum of the internal energies of each part. Mathematically, extensive properties often appear in equations that describe energy and work interactions. Take internal energy, for instance. It is an extensive property that relates to temperature, entropy, pressure, and volume through various equations. These equations help us explain how energy changes within a system. Another interesting aspect is that dividing one extensive property by another can yield an intensive property. For example, if you take mass, which is extensive, and divide it by volume, also extensive, you get density. Density is an intensive property because it does not change with the size of the system. Understanding whether a property is extensive is essential for engineers and scientists. It helps them predict how systems will behave when scaled up or down. This knowledge is vital for designing various devices, including engines, refrigerators, and chemical reactors that rely on thermodynamic principles. In summary, extensive properties are fundamental concepts in thermodynamics that describe how physical quantities change with the size of a system. They play a crucial role in understanding the behavior of materials and systems in various applications.